In this lecture, let us discuss what are open sets, closed sets and bounded sets, and then epsilon delta definition of limit. So first of all, let me define what is neighborhood. So let's say if you have a point A comma B and its neighborhood is defined to be, it's a circular disk. So it is a circular disk. So that, and how do you represent the circular disk? We are going to collect all points x comma y in such a way that assume that the circle radius is delta. Okay, so then what would be the distance between xy and AB? So the distance between xy and AB is going to be less than delta. Then we say that this x comma y is in the neighborhood of A comma B. Moreover, we are taking the radius delta, so we call delta neighborhood. And officially this is how we'll write. So the delta neighborhood of AB is collection of all points in R2 such that the distance between these two. And how do we measure the distance? This is how x minus a whole square plus y minus b whole square is less than delta. So this is how we measure the distance. So delta neighborhood means this: you're collecting all points inside the circular disk. And if you observe that, you are not including the domain. Sorry, you are not including the boundary. We are only including the points inside the circular disk. So this is what neighborhood means. So similarly, in 3 dimension, neighborhood is going to be a sphere. And sphere where its boundary is not included. See, here I am saying that its boundary is not included because of this. You see, we are taking strict inequality. Suppose if we take less than or equal to, then boundary is also included. Okay. So suppose if I write some n3 of 1 comma 2, so this represents all x comma y in R2, such that if you measure the distance would be x minus 1 whole square plus y minus 2 whole square is under root is going to be less than 2, because not 2, it is 3. Okay, so precisely this represents a circular disk which is centered at 1 comma 2 with radius 3. Okay, so this is the neighborhood of 1 comma 2. Moreover, we call 3 neighborhood of 1 comma 2. Okay, so let's define what are open sets, closed sets now. So we say that a set is open. Okay, before that, let me define what are interior points and exterior points and boundary points. Assume that you have a set S. Okay, we say that a point is an interior point if you can find a neighborhood around it which totally lies inside it. Okay, so we say such point is interior point. So if you can draw a circle around it which totally lies inside the set, we say that point is interior point. And similarly, you can define exterior point. So you can say that a point is exterior point. So this point is going to be exterior. Why? Because we are able to find a neighborhood around it which totally lies outside the set. Okay, but whereas if you take some point here, assume that you are taking some point here, right? So now whatever neighborhood you take it around it, which contains some points from inside set, and also which contains some points from outside set. So such points we call boundary points. So I hope it is clear what is interior, which totally lies inside the set, and exterior point which lies outside the set. And not only just lying outside the set, you should be able to draw a neighborhood around it which totally lies outside. For example, if a point is not in the set, it doesn't mean it is an exterior point. Okay, I'll tell you an example. Suppose if I take this interval, you consider this interval that is from 1 to maybe just 3. Okay, how do you represent this interval? Now I'm not including 1, but I'm including 3. So this is my interval. So 1 is not included, 3 is included. Okay, it is very clear that suppose if I take this set as S, it's very clear that 1 does not belongs to S. Okay, let me draw the set. So this is the set, right? 3 is included, but this one is not included. Okay, so now if you take this point 1, now if you take a neighborhood around it, so here in a real line neighborhood, it means it's going to be an interval only again. Okay, you can see that it contains some points from the set, and it also contains some points which are not in the set. So every neighborhood of 1 contains the points in the set and points not in the set. Therefore, this S, this 1 is a boundary point. Therefore, 1 is a boundary point. So if a point is not in the set, you can't conclude that it is an exterior point. It can be a boundary point also. Okay, so boundary point, it can be there in the set or it may not be there in the set. For example, you look at the boundary points of S. So 1 is one boundary, and even 3 is also boundary point. 3 is a boundary point and which is there in the set. Okay, so boundary points may lie in the set or may not lie in the set. Okay, so I hope it is clear what is an exterior point and boundary point and the difference between those two. Okay, so now let's take some examples. And let me define what is open set and closed set. Or in other words, let me take some sets and you tell me, I'll give you some points, tell me whether they are open or closed. I mean, they are boundary points or not. For example, if I take only first quadrant, so I'm taking first quadrant. Okay, so in the first quadrant, this is how I'm taking 0 strictly less than, x is less than infinite, whereas 0 less than or equal to y less than infinite. It means that x is strictly positive, so we are not considering this axis. Okay, so this axis we are not considering, whereas the region, this region we are taking. Okay, and also that we are considering this one. What is it? We are considering the x-axis. Okay, so this is what our set. So the first quadrant, right? So now if you look at the boundary points of this, so for example, if I take a point on the y-axis, what it can be? So if you observe that this can be a boundary point. Why? Because whatever neighborhood you take, which contains the points which lies in the first quadrant, and also which contains the points which are not in the first quadrant. Okay, so every point on y-axis is a boundary point, and also you can see that every point on the x-axis is also a boundary point. The same reason, because it contains the points inside the set and which doesn't contain the points inside the set. So therefore every point on x-axis and y-axis are boundary points. So let's write it. So boundary points are the points, or all the points on the x-axis and y-axis. So this I mean y-axis. Okay, so this I mean x-axis. But if you look at the set, where is the set? Here it is given, right? So in this set, if you observe that y equal to 0 is included. Okay, but x equal to 0 is not included. It means some of the boundary points are included and some of the boundary points are not included. Okay, so now let's define what is an open set. So we say that a set is open if every point of that set is interior point. Yeah, So if every point of S is an interior point, then we say that that set is open set. Okay, so it means what? No boundary point is included. So no boundary point of S is included in S. Okay, so for example, suppose if I take this set that is simply x square plus y square is strictly less than 1. So what does it represent exactly? Which is a circular disk centered at origin with radius 1. Okay, so it means you are going to consider all the points which lies inside this circular disk, but we don't consider the boundary. The outer layer we are not considering, because here we wrote strict inequality. Okay, so it is very clear that no boundary point is included here, because the all boundary. So if you observe that boundary points stays on x square plus y square equals 1. Okay, so but it is not included, therefore it is very clear that this set is open set. So let's define what is closed set now. Okay, the other way. So if all boundary points are included, then we say that that set is closed. So we say a set is closed if all boundary points of S are in S. Okay, so we have seen one example. For example, if you take an interval 1, 2 like this, 1 is not included, 2 is included. So this set is not closed. This is not closed. Why? Because 1 is not in S. Suppose if I take S to be this. Do you understand? Whereas if I take this interval 1, 2, yes, this is closed. Because the boundary points are 1 and 2, they are included in the set. Okay. So now let's look at the two-dimensional guy. Now if I take a set to be like this, all x, y in R2, such that x square plus y square is less than or equals to 1. What does it mean? It represents a circle. It represents a circle. It's now the boundary is also included, right? So it represents a circle centered at origin with radius 1. Okay, and you're going to consider the all points inside this set. So what about this set? So it's very clear that this set is closed. Okay. Alright. So you can see that this set S is closed. Why? Because the boundary is x square plus y square equals to 1 and that is included. Therefore, with this set is closed. Alright. So now let me take one more example. Suppose if I take this S is equal to all x, y such that where x greater than or equal to 0 and y greater than or equal to 0. So what does it represent? Which exactly represents the first quadrant. Okay, so it represents the first quadrant, and if you see the boundary of the first quadrant, the boundary is nothing but x equals to 0 and another one is y equal to 0. Therefore, and both the boundaries are included in the set, therefore this set is closed. Okay. Now what about the example that we have seen here, this set? So it is very clear that this set is neither open nor closed. So this set is neither open nor closed because some of the boundary points are included. Okay, so if you observe that y equal to 0 included and x equal to 0 is not included. Okay, therefore this set is neither open nor closed. And we have some sets which are both open and closed. For example, if you take R2, the entire set, okay, so generally it doesn't have any boundary point. Okay, so we can say that all points are interior points here, therefore this set is open, right? And even we can say that this is closed. Why? Because all boundary points of R2 are included in R2. Okay, And if you ask me what are the boundary points of R2, nothing, there is no boundary point. Okay, that's an empty set. In other words, you can define the boundary like delta S. When S is S, when S is a set, then delta S represents boundary. Okay, so we say that a set is closed if S union the boundary points is equal to S. So here, if you take R2 union with empty set, what is it you get? You get again R2. Okay, if you see the boundary points of R2, there are empty. Okay, so R2 union empty is R2. Therefore, this is closed. Okay, so therefore you can say that this set R2 is both open and closed. This we can say. Okay, so and also that empty set is both open and closed. So this is how we define open set and closed set. And then let's see what is a bounded set. Okay, so we say that a set S, let's say this set S is bounded. Okay, so if you can, okay, you just take a point inside the set, and if you can find a circular disk so that this set totally contains in circular disk, then we say that the set is bounded. Okay, it's a kind of bounded set. It means a set with finite area. A set with finite area, you can say it is a bounded set. So for example, if I take a circular disk, suppose if I take this x square plus y square is strictly less than 1, this is bounded. Okay, even if you take x square plus y square is less than or equals to 1, and this is also bounded. So don't get confusion between the bounded set and the closed set, right? So don't get confusion between bounded set and closed set. So if you observe that, I can say the first set which is open and bounded. Okay, and this set which is going to be closed and bounded. So let us see an open unbounded set. For example, suppose if I take S equal to all x comma y in R2 such that x is strictly greater than 0 and y is strictly greater than 0. So it means what? You're taking the first quadrant without including the x-axis and y-axis. Okay, you're taking this set without including x-axis and y-axis. So it is very clear that the boundaries are x equal to 0 and y equal to 0. They are not included. Therefore, this set S is open. Okay, is it possible to include this set? Is it possible to include this set in a circular disk? No, it is not possible, right? Because whatever circular disk you take, I mean, if you want to include first quadrant in a circular disk, you need a circle with infinite radius. But if you can keep it in a circle with finite radius, then only we say it as a bounded set. Okay, so it is very clear that this set is unbounded. Therefore, this is open and unbounded set. Okay, whereas if I take S equal to all x comma y in R2, so in this case we are taking the first quadrant including x-axis and y-axis. So therefore this set is going to be closed. Why? Because both boundaries are included. Now so this set is going to be closed because the both boundaries are included and it is unbounded. Okay, so try to know the difference between closed and boundedness. Both are totally different. Okay, so I hope you understand these concepts: open set, closed set and bounded sets. So now let me go to an epsilon delta definition of limit. Okay, so here in two variable case, what do you say? Assume that you have xy plane. Assume that this is the function y equal to f of x. Okay, So now we say that, so now I'm taking a point A. So from this graph you can observe that as you move towards this point, the function moves this way and the function moves this way, and when you reach A, so you'll reach this height L, right? So this is what we represent it like limit x goes to A, f of x equal to L. So this can be said in different way. So the different way is this: you take some neighborhood around L, that is L minus epsilon, L plus epsilon, and L minus epsilon. Okay, so you take some neighborhood around L, then we can find a neighborhood around A here, somewhere here. Okay, so we can find a neighborhood around A, so that every point in the neighborhood of A, it will be mapped in between these two lines. Okay, so here in this case the neighborhood is going to be, you take it with a smaller distance, so this is going to be neighborhood. So you take any point here, for example if I take this point here, its image is here, so which comes between this band. What happens, this f of x which coming between L plus epsilon and L minus epsilon. Okay, so in other words this can be said like, you start with any epsilon distance, okay, then we can find a neighborhood around A, so that the distance between f of x and the limit L is less than epsilon for all x belongs to this neighborhood. Or the same expression can be written like this: L minus epsilon is less than f of x is less than L plus epsilon. It means whatever point you take it from this neighborhood, right? So its image always lies between these two. That's what. So then we say that a function limit is L at A. So the same definition will extend it for two variable case. In the two variable case, now the domain is xy plane and the range is on z axis. Okay, so there the things changes little bit. So let me explain it again. So given an epsilon distance, you are able to produce a neighborhood around A, so that the distance between the function and limit is less than epsilon. Okay, this epsilon can be any small number. So it means, it says that if the distance between f of x and L is becoming smaller, it means f of x is moving towards L. That's what. Okay, so now let's see the definition in the two variable case. So we say that a function limit is L at a comma b. Okay, so if you give me any epsilon, for every epsilon greater than 0, there exists a delta greater than 0. So this delta represents the neighborhood of a comma b, the radius of neighborhood of a comma b. Okay, so in this neighborhood you pick up any point, so that its image f of x comma y is going to lie between L minus epsilon and L plus epsilon. In other words, the distance between the image and the limit L is going to be less than epsilon for all x comma y coming from this neighborhood. So this is what epsilon delta definition. Okay, so I hope you understand. So here if you observe that what you need to find is, given an epsilon, if you can produce a delta greater than 0, then we are done. What is this delta? This delta should be neighborhood of a comma b, the radius of neighborhood of a comma b. Okay, so let me quickly solve a problem. So here use epsilon delta definition to prove this. Okay, so first what shall we do? We write the function, so f of x comma y, which is given, and here L, the limit is 0 they gave us. Okay, so first what we have to do, if you start with an epsilon, then you need to find delta greater than 0. That's what our aim. Okay, and what is this delta? This delta represents the radius of the neighborhood around a comma b. So let's try to understand here. So what is a comma b? So here if you observe that the point a comma b is nothing but 0 comma 0. 0 comma 0 is the point. Okay, so now if I look at n delta of 0 comma 0, which means all x comma y in R2 such that x square plus y square is less than delta. Why? Because the center is 0 comma 0, no? So I directly wrote it like this. Therefore, so this delta satisfies this condition, x square plus y square less than delta. Sorry, under root, I should take under root. Okay. So when delta is the radius of neighborhood around 0 comma 0, then delta must satisfy this condition. Okay. So now let us start with epsilon. So let us start with an epsilon greater than 0. So what is it we want to do? We want to estimate the distance between the function and the limit. So what is the function here? X cube plus y cube over x square plus y square minus the limit is 0. And this equals, it can be expressed as, that's it. Now it is easy to see that this one, I hope you know this, mod a plus b. If you take mod a plus b, which is less than or equal to mod a plus mod b. So this is what you call triangular inequality. So using this result, I can rewrite it like this. Why? Because it can be expressed as sum of two expressions. One is x cube by x square plus y square. Other one is y cube by x square plus y square. You can actually write this total expression as sum of these two. And again, using the triangular inequality, you know that this expression is less than or equal to absolute values of these two individually. Okay, so if you want, you can write here using triangular inequality, so that you can write it here, or otherwise you can mention this property. Okay,